Today we show how to use IterX to solve Anthropic's take-home challenge on tree traversal optimization. The best result achieved with Claude Opus is 1,363 cycles, and Anthropic has stated they would consider hiring anyone with fewer than 1,487 cycles. Here, we demonstrate how to use IterX to directly achieve around 1,140 cycles without any troubleshooting. You can find the tutorial on the tutorial page, and all the code is available on GitHub. First, we download the problem repository from GitHub. Then we use the IterX API to create the task. We change the API key. The reward is simply the speedup, which the baseline cycle count divided by the cycles we achieve. We use a sample size of 8. In general, a larger sample size gives better performance, but it also costs more tokens. Since beta mode is currently free, we don't need to worry about cost. And for the initial setup, we just start from the code provided by Anthropic. Next, let's take a look at the task description, which is crucial for getting good results. The current limit for the task description is 25,000 tokens, so we can fit in a lot of useful information. As we can see, the task description is pretty long. We start by describing the task and making it clear that our goal is to achieve the lowest possible cycle count. Then, we include all the relevant code in the task description, for example 500 lines from problem.py, as well as submission-test.py, which contains the tests we need to pass. This part can be a little confusing. The relevant code should go into the task description, not the initial code section. The initial code section is only meant to include the code we want to optimize. The other sections in the task description include optimization techniques, where we ask the model to be aggressive when performance plateaus. We also list the requirements. For example, it must implement the build kernel method in the kernel builder class. Finally, we specify things to avoid, such as modifying the tests folder or changing other hyperparameters. Next, we create the task. Back to the console, and as can be seen, the task has been created. Next, we need to set up the reward function locally. We download the evaluation script and adapt the reward function to our own task. The default version is just a placeholder, so we replace it with our own implementation. We need to return 4 parameters: reward, code error message, correctness check, and details. Since we already have a comprehensive create task file, we can just ask Cursor, Codex, or Claude Code to help us finish the reward function. Here I use Cursor, asking it to finish the getReward function based on createTask.py. Here is the definition of the reward. If the code fails to execute, store the error message in the parameter code error message. Always set parameter correctness check to true. Any profiling information should be stored in the parameter details. It's important to pass the profiling information such as bottleneck utilization, slot utilization, saturation cycles back to IterX, as this is critical for achieving good results. This is the code generated by Cursor. By the way, you'll want to use the best model available in Cursor, like Opus 4.5. The function takes the code generated by IterX as input, writes it back to the file for evaluation, and then runs the evaluation using a subprocess. If the code runs for longer than 60 seconds, we treat that as an error. If everything runs smoothly, we compute the reward. Otherwise, we record the error message. We also extract the profiling information here and return all the results. We run the code. After a while, we check the page. IterX is able to generate code with the best score of 129.36, equivalent to 1,142 cycles. Feedback on using IterX is deeply appreciated. Thank you for your time.